Wonder if anyone's gonna join. Am I live? How do I know if I'm live? Okay. Oh, yeah. Okay, I can see the chat now. What's up, guys? So there is someone watching at least. I was thinking of doing kind of a chill stream to learn about PyTorch Lightning. Hmm. The fuck? Okay. Well, so kind of like PyTorch Lightning is like what I want to learn about. You know, I don't know exactly. So I've always used sort of bare bones PyTorch because I haven't really felt the need to have the flexibility that PyTorch Lightning can provide. So the main argument, I think, is that it allows for very easy multi-GPU training and distributed training and stuff like that, but also more modular code, so that it tries to standardize code in a way that you can sort of easily jump between projects, and it's quite easy to sort of understand it because it all looks similar. So I think that's sort of one of the main aspects of PyTorch Lightning. And so basically all I want to do today is just learn about it and try to go through, I guess, like the official tutorials of it. And this is going to be quite like not very refined and stuff, so it's just going to be me going through it. But we'll probably make videos on it when I learn about it that are more refined and more to the point. I've gained some weight. Now you're making me self-conscious. Yeah, I've been doing some stuff with Torch Serve lately. Might make a video on it. I think it's really nice to sort of set up an API. I only use PyTorch basically. So this is kind of why I want to learn PyTorch Lightning now, is because I've sort of set up multiple GPUs. Mostly before I've only used a single GPU. But can I put the chat somewhere else? Let's see. I have no idea what I'm doing. The chat disappeared now. Whoa. I legit just put like go live and here I am. Can I go on my YouTube? Okay. $19 watching? Damn. Is a master's degree important? I think it's not that important. Well, I don't know, it depends. But let's get started then. Pip install PyTorch Lightning. So like this is the main idea. You basically have code like this, which is code I'm used to writing, and the idea is just to make it more modular and convert it to something that looks like this. And I guess the idea is to sort of put all of this stuff into a single PyTorch Lightning module and sort of configure the forward step, optimizer, loss, and then at the end you just do sort of a, what I've seen from code is like you do a trainer and then you do .train, and that's similar to Hugging Face as well. So PyTorch Lightning and Hugging Face kind of have some similar functionality, but I usually use Hugging Face mostly for the models and the data sets, not so much for the training part. So I think in some way they are competing, but I think PyTorch Lightning is more the way to go when it comes to setting up the training, and then Hugging Face is more for the NLP models and data sets. At least that's my my view on it. All right, and they use callbacks and stuff. I don't know why, but I know that Keras uses these callbacks and stuff, and I never liked them. But I hope they work better on this thing. All right, but let's go through it then. Maybe we can take some code I have, some basic PyTorch basics. Let's see, maybe we can do just a simple CNN. And I've sort of set up this not too long ago. So before I used VS Code, and now I'm sort of wanting to learn. My setup is basically that I'm working from my Mac, and then I SSH into my sort of my server, a Linux machine. And I figured it could be nice to learn how to use NeoVim and stuff like that. So if you're a Vim user, and you know, I'm just learning about this. I just set up sort of the plugins and stuff yesterday, so I still haven't learned how to use all the plugins and stuff. But you can do really cool stuff. Like you have, for example, like if my code is very clunky or not nicely formatted, like this, or let's see, like this, I can do just, I have plugins, so I can use black. Okay, it didn't work. Maybe this is the best way, let's see. Huh, okay. I wanted to impress you guys, but it didn't work. Well, let's see. The idea is that it should format itself. No write since last change, all done. Okay. What I wanted it to do was this, so that it would set it on like this. But I guess it didn't maybe go through the maximum line length or something. But anyways, the idea is that you can use plugins that can do nice stuff for you, and then you can have this is a plugin that you can go back in time, like code you just changed. So maybe I fucked up the code, I can like go back to the original one. All right, but let's see. So what we want to do is you want to convert this into a Lightning module. I want to have like this chat. Can I like pop up? Yeah. Yeah, I do have a Discord channel. I'm not that active on Discord, but I want to get active because I want to have a way to sort of discuss with you guys and people in machine learning. So let's see if we can do this. We need to import PyTorch Lightning as PL. All right, so you specify one training step for a batch, and you send in a batch index as well. Okay. We can remove this. And we gotta use our learning rate, the correct one. There is only one. All right, what do we have to do? We have, so we're using MNIST. We have, let's see. All right, so we configure the optimizer here. We initialize it. We define the dataset outside. We set up a trainer, and then we fit the model on the training loader. So I guess we don't have to do much changes, I guess, on this code, maybe. So we should do this. PL trainer, limit train batch is 100. All right, let's just use that. And then model should be model lightning. On the train loader. So we should probably not have to do this. Does this work maybe? I don't know. We are just learning about it. What do you love about Lightning? Because I'm new to it, so I'm just trying to set up the basic training loop on MNIST. Oh yeah, we need to set up the, of course. Right, we haven't defined anything. Let's see. So we have to do this. Let's see. Indentation error. Oh. Okay, and then for a training step, let's see, we need to take this. Yank this. Okay, so we set up the layers here in our init. We define a training step. I wonder if we need to set the device here. I think no. And we shouldn't do this. So we should just do model of batch. And is it like a dictionary, I guess? Let's see. So Lightning enables full flexibility. Try any ideas using raw PyTorch without boilerplate, reproducibility and readable, simple multi-GPU training, GPU, TPUs, etc. Testing. So let's see. They did pretty much exactly what I want to do here. So they have the training step, xy equals training batch. Okay, so we'll do xy equals batch. We'll send in x here. We'll do y. No zero grad. They just send it in and then they compute the loss. So no backwards. Okay. I mean, it simplifies, I guess. So we just do this and we don't do step either. We just return loss. That's it. And then we want to have a validation step as well. Oh, and then we define backward and we do loss.backward. I guess we can do that. That seems, I guess it's good if you want to have some custom stuff you do in the backward step. But I wonder if it's necessary. Maybe you have default loss.backward. Let's go basic skills. Train a model. That's what we're trying to do. So maybe there's code I can copy paste here. Okay, so I guess we don't have to do this. We only have to define the training step. So we can skip that for now. Let's see if this works. CNN is not defined. Comment out that. Right. Oh, okay, well, let's see. Okay, so the self encoder. All right, so we send in the model, or we send in, let's see. Yeah, so, okay. All right, we got something working. Okay. Okay, is it working or no? Let's see. All right, so we defined the Lightning module. We set up hyperparameters, learning rate, and we didn't send any of that in. So can I set batch size? What does this do? No, it isn't working. Oh, I know why. I need to conda activate. Hopefully it works now. I set up this go to definition thing. Nice. All right, so it takes in what? GPUs. Oh, okay, so number of GPUs, I guess, to do remove in 2.0. Okay, I guess Lightning 2.0 is coming soon. Hopefully it won't be any major changes. Devices, TPU cores, limit train batches. Inference mode. Auto scale batch size. Is there nothing called just batch size here? So what's this? Limit train batches. How much of training data set to check? Okay. My goal is to start setting up or learn about PyTorch Lightning so that I can use it in my project. But right now, my knowledge is not very strong, so I need to learn how it works. So I was thinking I can just rewrite some of my basic code and try to convert it to PyTorch Lightning code. And so that's what I'm trying to set up. But I'm having some difficulty understanding how to do it. Like limit train batches. I don't know, why don't you just have a batch size? Yeah, I guess you could say that PyTorch Lightning is equivalent of Keras for PyTorch. I think the difference is maybe is that nobody uses, or I feel like Keras is the default maybe for TensorFlow as it was integrated. But PyTorch Lightning, I don't know if everybody, I guess most people in production use it, but I don't know if it's as standardized as Keras, but I guess it's becoming. I'm confused. Like in the example they don't have any hyperparameters and stuff. I feel like here you should definitely show how to set up, like what do you send into the trainer. Maybe they show it in another tutorial. Level 2, validate and test. All right, we'll set up the testing then. Trainer.test model data loader of test set. All right, we will test model lightning. We will test it on our test loader. Oh, I haven't done right. I need to do the validation step. Operates on a single batch of data. All right, hopefully Copilot can help us out. Pass. That's what it can do. Come on, bro. Fucking Copilot. All right, we'll just tell it. Same as training step, but validation. Maybe it can do it, but we don't need to calculate the loss. Okay. Okay. Yeah, Copilot is not the greatest sometimes. Let's see how they did it. Let's go back to this. Lightning in 15 minutes. I want to just see like a full example. Like, don't they have one that's full example? Because it's like, it's kind of, let's see. You can Google, I guess, PyTorch Lightning example GitHub. Examples. There we go. Here we go, maybe. So we have backbone. I don't like this, or I don't like that we have all the data sets and stuff from Lightning here. I don't know if PyTorch already has it. Why do you like make your own thing? Okay, on the validation, we compute the loss. All right. Self of X. Self.backbone. Okay. Should we return it? Here we return it. Here we just log it. Self.log. And log is what? Okay. All right. So then we should change this stuff. We should definitely do like a model outside, I think, because this is going to be copy paste code here, which is not the best. I guess it's fine. Like this. All right, does this even work now? Let's see. No test step. All right. Oh, okay. So we need to write. That's what Copilot was doing. It's just smarter than I am. Okay, cool. Copilot. Batch index. We do the same thing again on this. But I don't think this is correct, right? This is exactly what we're doing in the... Okay, it is. All right, predict step. We want to have the predict step. Because I want to compute the accuracy. Predict step. Ooh, this is ugly. Yikes. All right, we'll try it. Test metric, test loss epoch. Okay. All right. How do I set the device? Because it's kind of slow now. Device. Unexpected keyword. Oh. Oh, I guess it's here. Device, devices. It should be optional union of list. Okay, so it can be a string. All right, so we'll just do just set device here. Devices is device. Okay. My data module. Okay. I guess we'll do that afterwards maybe. Trainer.fit. Oh, okay. That's how you do it? I'll try it. And then if you want to use multi-GPUs, accelerator, CUDA. I guess if you want to specify the GPU you want to use as well, can you do GPU 0 or 1? Supports passing different GPU, TPU. So I'll start with just doing devices equals 0 then, I guess. This is nice. Okay, shuffle false. And I guess we should do this. We can try this later though. So I think we should do, this is kind of ugly. I think I should do what they did. So like a common step. I don't know, like people that use in Python, you don't have private functions, but people still do this. But I guess it looks nicer maybe. So for the common, we'll do batch and batch index, and we'll just course, it's here. Yeah. Cool. All right, that looks better. A little bit cleaner. Now we can, and now we got the GPU working as well, which is nice. Let's see if we can remove that error. If we do this, I don't know what that is actually. Set flow 32 mathematical precision. I have not done that before, but at least we got rid of the error. Yeah. And we can set data loader num workers. I mean, this is nice if it works in, well, I guess it's in Windows, it's a problem, but usually when you set num workers and stuff, all right, you saw that? Now it worked. You saw black, like how the code was pretty badly formatted. This is what's nice. I think everybody should use black like this, and you just do, what? Now, huh, I wonder why it didn't change it now. Because it did change it just now. Is it because it like knew I manually changed it back or something? Oh, let's see. All right, if I do, now I changed it. But if I change it back, it doesn't want to change it. That's interesting. Not sure why it does that. Invalid syntax. What? All right, so now we have that. Maybe we can remove the error. Now we shouldn't have that, at least. The data loader does not have many workers, which may be a bottleneck. Consider increasing. Try 12, which is the number of CPUs on this machine. Wow, 12? I have never used 12 as the number of workers. That's a high value, but we can change it to 4. You have defined a validation, but I have no validator. Skipping val loop. All right. Yeah, we can skip that. And all right, so now here's the power of, well, first of all, actually, I want to use, I need to set up so I get an accuracy. So how do I get the accuracy? Custom callback. Okay. Is that what we need to do in order to get okay, how do we create a callback? Let's see. What tutorial is that? They have, let's see, callback. Okay, let's just try that first then. So we'll paste that in. Okay, training is starting, training is ending. All right. All right, that's cool. And then let's see. So where do we want to call back? We want to call back on the test, I guess. I just want to test it like after on the test set and on the training set like this. This is what I was expecting. And then you write some early stopping. I mean, this is nice stuff though, but the quantization, aware training. I mean, this is really cool. I mean, this is, I guess this is like some of the power of PyTorch Lightning. And model pruning stuff. I mean, you can do all of this with PyTorch, and it's not that difficult, but I understand what they mean when they say they want to remove the boilerplate. The only problem is, in general, like I have a lot of resistance to using these stuff because there is, in many cases, you don't know what's behind the code, and so you run into issues and they do all sorts of stuff for you, and then when you're trying to debug, things are just really difficult. I felt that way with Keras and also with Hugging Face as well. I kind of like doing it on my own, but there's definitely a utility in that. When you've done it yourself once, then you sort of know how it works, and then you can, I guess, use these things, which is nice. But yeah, I don't know. It doesn't make logical sense. I think we should definitely use these things. It will make us more productive, but it's just like resistance because I know that there's going to be bugs and you don't know what's going on exactly. So yeah. Yeah, I'm using NeoVim, but I'm not very good at it. I'm just learning about it. I've went through the Vim tutor and set up my first plugins and stuff, but it's not. Yeah, I don't know if it's good or bad, but I have the basics of what I want. No, like you have to use it. I use Hugging Face because I mean, you have to, but there's sometimes errors that I've encountered that you don't really know where they come from because you don't understand the code exactly. But let's see. So if I want to use a callback, I want to use a callback on like accuracy. I mean, this is weird though. It's not. It's like a metric. Like I don't want. This is kind of dumb. PyTorch Lightning, get accuracy. Torchmetrics. All right, so we need a metric. We have self.accuracy, torchmetric.accuracy. And then we have training accuracy step, training epoch end. All right, let's try that then. This is quickly getting. We need to integrate a lot of stuff. Okay, so we'll set that in. No, wait. Oh, we need to have multiple. All right, so we'll have one for the training. We'll have one for test, I guess. All right, let's just start with the training accuracy. So we want training accuracy on, where do we set it? There we go, on training epoch end. I wonder if Copilot knows these things. So we have training step. Yeah. And then we get batch value of it. We'll do this in this also, train epoch end. Bam, let's go. Hopefully this works. Outputs. All right. Oh. Oh. Okay, so I am getting a number, it's just not showing. Is it? Or yeah, no, it's not showing. So I want to include it here. I mean, here we are logging. Not sure why it's not showing. I guess maybe we need to set this on step stuff. If we go to log, we set on step on epoch. Logs at this step. I mean, that's probably what we want. Or maybe on epoch, but it's computing it, so we might as well get it on no, we're still not getting it. I mean, that's a bit confusing because we are, where are we logging the loss? I mean, okay, wait, so we're not logging the actual loss here. Okay, so it is working, but I really want to have this as I'm training. And it's only showing the loss, which is and I also have no idea how to use these. So okay, the learning rate makes sense. We can remove this though. The batch size we're not using this. We're not using any of these, so we can delete those. But this I don't really understand. Limit train batches. Why do they call it that instead of just the batch size? Not sure. How much of training data set to check? Oh, to check. Default 1.0. Num batches. Okay. We'll just set that. We'll remove that. And how do I set the batch size? Is it here maybe in the fit batch? Oh, right. Oh, never mind. I thought we weren't using the batch size, but it's in the data loader, so that makes sense. No? Still no? What? Now we're even returning it. And logging it. That is so strange. So I was thinking if we return it like this, because how it's logging now, how it's getting the loss is in the training step, right? So we're computing the loss and it's computing it. I mean, we can call it my loss and we'll see if that's what it does. If it's correct, because the only thing I can imagine is that we're setting it here. The loss key needs to be, okay, maybe there's, okay. Oh, okay, I thought it was general, but maybe it's specific. So we can only call this like loss, and this should be something else. What do they call it then? Train accuracy step. Is that what it should be called? But that's what I called it before, so I don't think. And also, where do these logs even show up? I'm not sure. What? Maybe this is what I'm wanting to do. Customize the progress bar. So slow. Make a roadmap for deep learning. Like what type of courses you should take, or do you mean like a roadmap of the different areas and overview and stuff? I don't know what happened to their documentation. Now it's working, okay. Okay, wait, so there's an argument. Johanna says there's an argument in the self.log function to log the progress bar. To log to the progress bar. Yeah, that's exactly what I want to do. So if I go to this, if true, logs to the progress bar. Okay, that makes sense then. Because I was a little bit, so it automatically logs the loss, but if I set it here, it's not gonna log it. So I don't know what this is doing. Why am I returning this? But yeah, so we can just do like this. Return the loss and then set progress. And hopefully that will work. Let's see. No, okay. Prog bar. Okay. I mean, that's let's see. Okay, that's nice. All right, so now we get the training accuracy. Venum. Not sure what that means. Okay. All right, so if I do devices 0, 1, it should hopefully be multi-GPU. No. Okay. I don't know if it's actually beneficial to use multi-GPU. I just want to know how it works. All right, so it's obviously overfitted at this point. All right, but that's cool. And we can set devices if we want to specify exactly which ones to run. That's nice though. I mean, I like that. Pretty much no hassle. I wonder if you can also choose the type of the multi-GPU training you want to do. Oh, which experiment version you're running. All right, so each time I'm running, it's gonna increase vnum. All right. All right, I mean, this seems all right, I guess. So what else do we want to do? I want to know kind of how you define, let's see. First of all, I would like to know how to do this thing by myself, this metric thing, and also the callback thing. So I guess this is how you you get the trainer and the PL module. Not sure what that is. And let's see, we're still getting error. Find unused parameters true was fine in DDP. I mean, we can use one GPU for now. Not sure what that is. Oh, I started recording. Oh no. How do I do that? How do I end that? Okay. All right, at least we don't get any errors and stuff now. I would also like this though to print on a new line each time. I don't want to have sort of that it overwrites the previous ones. It would be nice to see the train accuracy as it develops. I mean, you would probably use Tensorboard, so it's no big deal, but it would be nice to know how to configure that. And then yeah, these stuff as well. I guess these logs are gonna be present in Tensorboard. I hope you can just use those logs in some way. That would be nice. And then wonder what it is I want to change now. I mean, I want to I mean, this seems to be working. let's go back to the tutorial stuff. All right, so we learned the basics of training a model. You add imports, you define, we didn't do this, but they define the PyTorch init modules separately, and then they integrated them in the Lightning module. They define a training step, optimizer. They get the data set, get the training loader. So we did that. We didn't do a validation set. Maybe we should do that. Data random split. Where did they import that? Is that PyTorch? All right, so with the val loader, we want to use this. Wonder if they have like a val loader. Yeah, val data loaders. Okay, that's nice. So val data loaders equals val loader. All right, and then we need to define the validation step. Cool. It is running the val stuff, but it's not printing it. Let's see. It seems to me transformers can view each token as a node as what is in GNN. Is it proper to consider transformers as a special kind of GNN? I think they, I don't know if it was a paper, but I think they proved that transformers can be viewed as a special case of a GNN. Oh wait, so I think transformers are a special case of a GNN. So GNNs are more general. So if that's true, then you should probably watch or probably learn about GNNs, as they are probably more general than transformers. Yeah, no problem. Yeah, I'm not that used to streaming, but I thought it would be cool to just to start like, what would be cool is to start building stuff on stream, like projects and stuff. But today I'm just wanting to sort of get a good workflow with PyTorch Lightning. I think that will be a solid improvement over using just bare bones PyTorch, but it's always difficult when learning new workflows. So it's a little bit clunky now, but it'll get better. And once I learn, I'm gonna make videos on it, I think. Yeah, I have a Discord channel. I'm not that active on it, but I'm gonna become more active. But I check it sometimes. It's in the community post on my YouTube channel. All right, so what I want is pretty much now to just get, like, it's okay, but I don't like that this restarts, like, and you saw the validation right there. I guess it's logging, but I want it to. Yeah. not sure how I make it print on a new line instead of continuing. Progress bar, PyTorch Lightning. What is it called? Continuation or something. Their documentation is not that fast, or maybe it's my internet connection, but I don't think so. This is super slow. Hey, thanks, man. I appreciate it. Wow, this is super slow. Goddamn. Okay, let's go to. Maybe it's faster if I search. Okay. Leave equals true. That's what I want. Okay, so alright, maybe it's not too important now, but I would like to know how to do it. I mean, I'm setting the, it should be in the trainer or in the fit, I guess. All right, and then we can set the precision as well, which is nice. Okay. And then like how you would use learning rate decay and stuff like that as well. I guess that's a callback. But yeah, I guess that is a good starting point. I'm just trying to think like what else I would like to change here. But maybe we can just go through the rest of these things. So let's see, close other tabs. Learn to save the model. All right, we can do that. Load from checkpoint. Okay, so I want to set float 16, precision. Okay, that was easy. And if I want to save the checkpoint, Yeah, I mean, you can't do this, obviously, but maybe there's a better way to do it. Save checkpoint to at every epoch end. Okay. I feel like it was slower now than when I was using 32 precision. Yeah, I can get it. Let's see. I'm from Sweden. Where are you guys from? Yeah, I mean, now like my tutorials like are more refined, obviously, and that's when I've learned stuff. But this is a lot more messy and sort of how it actually is in real life, I guess. I think a lot of people watch some of the tutorials and they're like, "Wow, he knows everything," but the reality is like I'm just like you. Oh no, what did I do? Oh goddamn! This is what's nice though with I've set up, so I'm using NeoVim with Tmux. So this is oh my god, I have different keys for everything. Let's see. I hope this is the one. No. Yes, okay, good. Now we can do Tmux ls and we can do attach T Lightning. Oh, I closed it. All right. No, okay, there we go. There we go. So this is what's nice with Tmux is you can have a session. I don't know if you guys use it or not, but you can have a session and then you can just sort of attach back to the session, even across reboots and stuff like that. So this is really nice if you are working on an SSH machine like I am now, and then you can just, if something happens to your connection or you accidentally quit your terminal, then you can just reconnect back and you have everything as you did before. Yeah, I can do that. I remember I've done that once in the past. I've implemented srgan or something like that on stream. But, you know, it's like it's uncomfortable showing how messy it is because you make all sorts of dumb mistakes, and it's much easier to make a video on something that you've spent a lot of time on and you know exactly how it works and you can explain every detail. But yeah, I might do more of these kinds of messy videos. All right, let's go through the so all right, so we have this. You can load it at, save it at every epoch. We can make sure that that works. All right, so if we do ls, we'll get lightning logs. And we have a lot of versions here. All right, so wait, we'll do. What? Oh, it's called lightning. All right, so we have, now we're doing this. Okay, and then in version 0, we have checkpoints. All right, and we also have, all right, we have the TensorFlow or Tensorboard events, I guess. So maybe we can open up a Tensorboard here. All right, that's cool. All right, so it's cool. It saves it automatically. I guess it's by default as well. So every epoch it's gonna save. All right, that's nice. All right, let's go back. And also you can do resume. Wonder if it does that automatically. Yeah, I guess it does. So wait, we'll see. We have train for. Oh no. Okay. What just happened? Okay. Oh. Like I literally got this, like fixed this yesterday. No server running. All right, we'll just Tmux. There we go. So if it starts at like, let's see what it starts at. No, so it's probably resetting, I think. Yeah, so you need to, I guess, specify to resume. Okay, let's see if it starts from there. Checkpoint path. Oh, in the fit function, okay. You have to specify all of this. Oh. Oh. Okay, wait, so this should be... That's how it's supposed to be, I think. Kind of confused over that. MNIST model, lightning logs, version 0 checkpoints. I think that should be correct. All right, so now it worked. All right. Okay, so now we've learned how to do default saving directory, how to load it, and specify which checkpoint to load. And then if we go back there, and I guess we go to version 1. No? Okay, so it continues from that one, and then no, we do have a versions 1. All right, so version 1. But it didn't save it. I guess that makes sense. So it's just logging this run, but it's not saving the model. It's saving it at the same place. So it's overriding it, I guess. I guess that makes sense. Oh, that would be cool. That's a good idea. Like, basically like a paper review discussion. Let's see, did it change it? So ls MNIST model version 2. Yeah. All right. So it's wait. Okay. It did save it, but it's using. Okay, that makes sense. So we have this that we're loading from, but in every we're also saving a new one. Yeah, that's I guess what you would expect. Yeah. So I think that's all right. That's a good start for PyTorch Lightning. I definitely think I'm gonna like this. I mean, just that you do this, like you set precision, easy. You do all the callbacks. You can do these custom callbacks and stuff. I think once you get used to it, I think it's gonna be a much nicer workflow. And also with the multi GPU and stuff. I wonder if you can set also like if it should use data distributed parallel or all of these new fancy ones that exist, like the zero multi GPU training and stuff. I wonder if it says here zero. No. DDP. All right, that's cool. I think we have a basic understanding of that. Enable early stopping. Yeah, we can do that. All right, so you do callbacks, early stoppage, mode min. That's pretty easy. Just copy paste in that. So let's see if it works. Epoch 2. I feel like it should stop about now. No? Still improving? Ran for much longer than I thought. Maybe it's not working. I feel like that's way too many. If you look at the or I guess like the training accuracy is not 100%, but maybe it's to do with the learning rate. Okay, now, okay, so it did work. That was a long run though, so 20 epochs, but that was pretty nice. You can do, oh, okay, we did it on validation loss. You can also do it on accuracy. You can specify more stuff as well. That's cool. All right, that's level 2. Level 3. We're cruising, baby. Cool script. Can you hear this, by the way? On the stream, if anyone's watching. Yeah, take care, man. Pie. Yeah, I'll definitely think about what you said. It's a good idea. Just learning some PyTorch Lightning. Just going through the basic tutorials of it. So wait, if I do this, can you, let's see. Let's see, maybe I need to add audio input capture.
To help you save time debugging,
Now I guess you should hear it, maybe.
Fast dev run flag. You can think about this flag like
oh no, wait, okay.
It will touch
Let's
every
see.
piece of code in your model. Your training loop, validation loop, and test loop. That means that it can uncover bugs without you having to run your model or do a lengthy training. The best way to use this flag is to turn it on when you're developing.
I have no idea if this is good or bad. If you can hear it. Let me know if it's too loud or if it's not. But this is cool though. I feel like they've made a good job of having these tutorials, because I know they've been doing some video tutorials and stuff as well.
Developing. So and nice. When you make a change that you think might break something, you run the trainer with this flag and it will just run through all your code at once. This flag will not generate logs. It will not take checkpoints. but instead it will touch every line of your code. Lightning has a flag called overfit batches. A trick to sanity check that your implementation works is to take a single batch of training data, and if you set it to a float like 0.01,
that's actually really
it will
nice.
pick 1%.
This is like one of the, like a really good advice for the thing you should do before you do anything else is make sure you can overfit a single batch, and it will save you a lot of time. Fast dev run runs 5 batch of training validation. That's nice too. All right, I like this. Let's do that. Let's try it. I guess it should be in the dot. No? Okay. Okay, it did not. Maybe I need to remove this. All right. Cool. That's really nice. And then overfit a single batch. That was not included in this text though, I think.
Implementation works is to take a single batch of overfit it as much as possible. You're going to train like one, it will pick a single batch.
That's nice. But it only ran for 5 epochs. I guess you can specify it, but that's really nice to know. That's definitely something I will use. All right, I'll do that. Thanks for the feedback. Have you guys done a lot of work with PyTorch Lightning, by the way? I know it's like really popular, but yeah, I haven't used it, so. But this is really cool, nice stuff. I like this. All right, bottlenecks in training. Profiler. Okay, so maybe we should just do profiler with fast dev run. Okay, and then we got the times, mean duration. That's pretty nice. You can see, I guess, if the data loading is the limiting factor or or if it's something else. I think it's starting from the point that we ran previously. So it's running from the checkpoint, which ran for 1 epoch, and then we need to set a higher number. So training epoch is taking most amount of time. Run training batch, optimizer. I mean, these look good at least. And then I guess here we can see that maybe we're 10% on the data loading. I haven't used these profiles that much, but I think I'm gonna start using them. That looks pretty nice. Maybe you should definitely do that in the beginning. So you run for you do this fast dev run for a couple of batches. Or actually, maybe the workflow would be like you overfit a batch, make sure that you can get 100% accuracy. You add the fast I guess you do the overfit batches, fast dev run, and then you run the profiler on a couple of, I don't know, 50 steps or something, and then you just see if there's a huge bottleneck, and then you start your training. It's been so many times I've sort of been realizing later on that data loading has been a limiting factor. What I usually do is just like NVIDIA SMI and then make sure that these are using full power. That's how I've profiled that they're actually being used. And then you have an advanced profiler as well. I guess I will do like a deep dive on each of these, but it's nice to just get an overview of what exists. And these metric we already did. Nice, and then we can just use a log directory with Tensorboard. That is sweet. All right. Let's see, that was level 5, and then predict. curious what the other things will be, and then you can do so much with this library. I didn't know about all of these things. All right, that was a good start to PyTorch Lightning, I feel like, and a good first stream. I think I'm gonna do start making videos on PyTorch Lightning. Might do a simple introduction one. I don't know. I guess they have already done it, so maybe. I like. I mean, these are nice, but they're sort of short and to the point. I'm thinking I'll make more sort of like I did here to set up everything from scratch. So how would it look like in PyTorch, and then how can we convert it to something that's to something that uses Lightning instead, and then sort of understand in depth how each of these can be used, and then maybe introduce them one at a time. Now we've sort of, these are kind of scattered, right? I don't know exactly how this callback works, but it's so you can introduce functionality one at a time. I don't know if they've done, so this one is like just all of these extra arguments, which is super nice, but I don't know if they have, maybe here. Yeah, so these are the ones pretty much.
My loss is gonna be a torch, and some very caring person has made utils. So nice. All right. Okay. When I generate my model, this model lives on this first the output of the first hidden layer. So I think
I guess this is pretty much what we did today.
Okay. Close to your layers, so these layers get the gradient directly from your during the.
But this is not with PyTorch Lightning.
Gradients,
yeah.
So we don't keep the whole.
Why you don't want to do this is because sometimes, for example, if we're not doing MNIST and we're doing ImageNet or some other thing, you need to know what the number of classes is, right? And that's going to come from your data. So a lot of times it's useful to know what that is. And so sometimes you just want to define that on here.
Yes, I see.
Yeah, okay. So it's the same thing that you had, I just pasted it.
Mm-hmm.
And then we have these kind of splits, right? So, so I'm going to leave this as this right now, and I'm going to.
This is pretty much exactly what we did in the stream.
And then you call fit on it, right? So you pass the model in, and then you call fit. And then what this will start doing, okay, wait, so I guess configure optimizers, right? So you put this keyword in here, loss, put that J, and then you go ahead and you init your model, and then you fit it, right? And then it starts training, and then you see this nice progress bar. So Colab is going to have issues. So I'm going to pause this for a second, because that progress bar is updating too fast for Colab to keep up. So it's going to freeze my UI, right? So we're going to use the trainer flag here that's going to slow down that bar. Well, the training is the same, but it's not going to update as frequently. So it's only going to update that progress bar and do all this CUDA stuff, right? So we have to I don't even know where the model is anymore. Yeah, so we have to do this. We have to call the model to CUDA. For each example, we have to do this CUDA.
I feel like this is a nice thing, is that we don't have to define the device. So if we're using, it becomes easy to just change on a single place, and you don't have to do all of these .to device everywhere.
And then here we have to make sure that things were detached and on the right CPU and stuff to get this accuracy, right? So let's not do all of that in Lightning. We're just going to set this little argument called GPUs, and we're going to say 1. And then now that's going to train on GPUs. So you see it's available and we're using it.
Okay.
So
it's saving the best checkpoint with respect to the
loss.
Which one? We only have
the one. Yeah, exactly. So in this case, it's only using the training loss. So it's literally it's not great because it's not cross-validating or doing validation. Yeah. So it's literally just going to save the minimal loss, which is in reality, you wouldn't do that, right? But let's log this first, right? So have to deal with any of that.
Okay.
So it's just automatically done for you.
I never used more than one CPU. I don't know. I don't know.
Yeah. Well, now you will, right? So, okay. So we calculate our accuracy, and we wanna show that in the progress bar. So I'm gonna show one is the log. Now we have this accuracy, and it's printing to my progress bar. So I don't have to. So in this, in this return statement, you have 3 main reserve words. One is the log, right, which should show next.
Oh, okay. I didn't know you could do that. So you set p bar to be the ones you want to add as a dictionary, and then you set progress bar to that. I mean, that's nicer probably if you're gonna have many of them. I'm not sure what we did now. We did what did we do? Here we did self.log that, and then we said progress bar equals true. What did he do? I mean, that's nicer, I think. He just did accuracy, and then he did p bar equals like this, and then that thing, and then we can, I guess we still want to log it, but we don't need to send it to the it's not showing. Oh, we should do accuracy here probably. No? Maybe they've changed it. I guess this was 2 years ago. Undo tree, baby. Go back. This thing. Let's go back to that. That looks better.
The loss.
I'm just showing off all my plugins I got. Look. All this. Undo tree, baby. And I got this also. Look. Damn. I don't know how to use any of these yet, but they're fancy. Yeah, I'll definitely continue learning about this. Like, I need to I don't know, like, do you guys use Hugging Face, because I know Hugging Face also has a trainer, so I'm kind of confused as to how to. I guess you can. My idea right now is to integrate so that you define everything in PyTorch Lightning, and then you take the models and stuff from Hugging Face and integrate them in PyTorch Lightning. But I feel like Hugging Face is trying to do that by themselves. And so it's sort of the same thing being done in Lightning and Hugging Face. And I think it's just a little bit confusing. I don't know if you guys have any experience on what you're, how you do when you're working with those two libraries, but
specifically, and then you want to show stuff to the progress bar. You have this progress bar, researchers, research scientists. We have people from Facebook where you want. So we want to pull out the, let's just say, what do we want? The loss. Sure. So you asked me how. Yeah.
Thank you.
Cool. Okay. So now we get rid of that.
Del, right? No def.
Oh yeah. Sorry. Good points. Okay. Del. So we'll delete that. So now we have this trainac, which is here.
No.
Sorry, Valak.
Well, yeah. Okay, now I feel less.
Great. Less anxious. Okay, so GPUs, and then you want to do this on 32 nodes for some reason, right? Like this is a giant network. Now I'm going to train.
So this is the biggest strength, obviously, is that you can just set the number of GPUs and it'll automatically do it for you.
32 times 8 GPUs.
Hold on. What are the nodes?
So each node is a machine on a cluster, and each node has so many GPUs on it, right?
But
so,
how do you talk to between machines?
Yeah, that's the beauty of Lightning. You just have to spin up the job and it'll talk between machines, right? So if you submit this to a cluster, for example, like Slurm, if you submit this job, then as long as you specify in your Slurm script that you need 32 nodes and each node has to have 8 GPUs, then Lightning will just know how to do that automatically. What's going to happen is this. If all those nodes share the same file system under the hood, then you want to download the data once, right? Because why would you download that?
All right. I think I'm going to take a break, eat some lunch. It was a cool first stream though. And we'll see if I make an introduction video to Lightning today maybe. Or if I'll convert some more project. But this definitely think I'm gonna use this for future projects. Just use PyTorch Lightning as default. All right. All right, cool. All right, thanks for joining the stream. And let me know, like this is the first stream that I'm doing, so I have no idea what I'm doing basically. But it was nice to see that everything works, and that if you have any ideas of streams I can do, maybe it would be cool to code project, sort of live coding some project, or going through some paper, or just now like learning about some library and chatting. Let me know what you think, and I'll stop the stream now. All right, have a nice day, guys.